Hello, in this episode of Exploring Rust, we're going to take a look at reference counting in Rust. So I'm continuing to work through the Rust documentation. I think this is section 15, so I'm more than halfway through that. And I think there are about 22 sections in total, so the end is sort of in sight now. It's going to take me a few more months to finish the whole thing, I think, but we are getting there. In this particular video, I'm going to take a look at reference counting. And I found the Rust documentation a little bit hard to follow on this. So I basically just created my own example here. I used Microsoft Copilot to figure out a lot of the details of this. And with the help of that, I managed to put together some kind of simple example that makes sense to me. Which you can also find, we're going to go through it here, but you can also find it on blog.kforprogramming.com. And I think this is pretty straightforward. So the idea is, sometimes you have a situation where you have an object that you've created and you want to have multiple owners of that object. You don't want that object to be dropped until all of the owners have been dropped, typically because they've gone out of scope or maybe they've been manually dropped or whatever. And reference counting allows you to do that. We can have an object that has apparently multiple owners, and only when all of the owners have disappeared will that object be cleaned up. An example might be if you have a tree structure where you want a node in the tree to appear at multiple different points in the tree. How do you know when to clean it up if you've got multiple things that refer to it? And that would be a typical situation, I suppose, for doing reference counting. So first I'm going to need some kind of structure that I can create objects from. Let's have a struct. I'll call it person, and this is actually being filled in by, GitHub Copilot. How can I turn that off? Because I don't really like it working in videos. And this isn't even really quite what I intended to type anyway. I think if I go to this control here, no, that's just for toggling chat. Let's try view appearance status panel, status bar maybe. And in there, if I click this, I can untick code completions. Let's get rid of those for a moment. Okay, that should do the trick. I do find Microsoft Copilot extremely helpful. I'm making the code for a course on C++ at the moment. That's a course on modern C++ that goes right from absolute beginner level to hopefully very advanced. And Copilot actually saves me a lot of time with the typing. It doesn't always predict exactly what I want, but often it does a pretty good job, and then I maybe just have to edit it a little bit afterwards. But when I'm learning a language, like I'm learning Rust right now, I find it very unhelpful because I really need to type this stuff for myself in order to learn it. So let's create a struct person, and that can have a name. Let's have a name of type string. And apparently the difference between using string with a capital S here and like a strut ref is a question of ownership. Do you want this struct to fully own the string, as it will do with a kind of string type like this? Or do you want it to just refer to a string that exists somewhere else, which would be the case if you had a strut ref here? So normally that's why you would want a string with a capital S as a field in a struct, apparently. I'll also just give this a age of type. That's we can't have a signed age, so let's make it, in fact, U8 I think would be good, because no one's going to be more than 256 years old, are they? 255, and they're not going to have a negative age, so I think that would be all right. Now I'm going to put a bit of implementation, and I just want to implement the drop trait so that we can see when this person is actually dropped. So if we have impler drop for person, and then function drop with a lowercase d, that takes a mutable reference to self. We covered this last time, and in there all I want to do is say something like person dropped. So person dropped. Let's put the name in there actually. So let's say in here a couple of brackets, and then I could use self.name hopefully. Then I could create an actual person. So I could say is it let? It's let, isn't it? Let I'll just call it P equal person. We put those curly brackets in. That's got to have a semicolon on the end of it. Let's say name. And now, because we can't supply just a reference to some hard-coded string, but I can say string : from. Let's call him Bob. And let's say Bob is 32. So all of that should work, and we should see this statement coming out, because when P goes out of scope, we should see that this person Bob has been dropped. So let's go to a terminal and try to run this. I will do cargo format, and there's already a problem. Oh yeah. Yeah, so where are we? I just need to put age here. I need to identify the field. Let's try again. Okay, good. And we'll do cargo run. Okay, there's some more problems here. Expected, comma, found keyword, self at line 9? What's going on there? Oh, no. Is that in the right place? I think it is, isn't it? So if I didn't have mute in there, that would look like this. And I'm sure that's right. I remember that. And if we try to run that, I've got an unused variable thing going on here. I'm going to have to just fix that. I always forget about that. So we can turn that off with hash. This is going to end up being the bit of Rust that I actually remember the best. I've typed this so many times now. Allow unused. Still have not investigated the syntax of it much though. But anyway, we'll do that probably later on. Let's do run again. I don't know what the problem... Oh yeah, wait. I've just missed a comma off there. Okay, try again. Yeah, and then we've got the mutability thing. So, I mean, this wasn't actually the problem. I need mute in there. And then if I run it... Okay, yeah, it says Bob dropped. All right, so that's good. Now we can look at reference counting. So I need an import here. I need to say use standard RC and then RC with an uppercase R. And then instead of just creating a struct like this, I'm going to create it using a call to the new method of RC. So here I'm going to say, what's that called? Standard RC. Well, I've imported RC, so I can probably just do RC : new and then wrap this in round brackets. Let's actually change this to P1 maybe and see if that still works. Yeah, and it still says Bob dropped. So RC of course is short for reference count or reference counter, and it counts the number of references that we've got to this person. I think it will only deal with immutable references. If we wanted more references that we wanted to count that were mutable, we'd have to use some other technique here. Although of course we can only have one mutable reference anyway to a thing, so maybe that makes no sense. But I think the thing that it refers to has to be immutable. Not 100% sure though. Now I can use a method, I suppose, called StrongCount to count how many references there are to this person object. So let's do print line, and in here, let's put, I'll just put ref count and a couple of brackets, and I think what I need is RC : strong count. I might have to check my notes. And we pass in a reference to this P1 variable of type RC that I've created. And I think that'll get us a reference count, which should be 1, because there's one thing now that refers to this person object. When I run that, it says ref count 1, so that's fine. But now we can create more references to the same object. So I can say let P2 equal RC clone, and I can clone, and I think again we want a reference to P1. And when we've done that, we should find that the reference count has increased. We can actually use this strong count thing now either on that or on this, and it should give the same result either way. So let's go to a console and run it, and you can see it says ref count 2 now. Let's create one more for good measure. So I create another one, P3, which clones P1, and then we do the reference count on P1 again. And now when I run this, so we've got 3 references, and at the end it says Bob dropped when all the references go out of scope. Now let's investigate this a little bit more. So I should be able to drop any of these references. I think I should be able to, for example, drop P1 and then we can check the reference count. So there is, I suppose, there's a kind of parent-child relationship going on, isn't there? Is this kind of like a parent and these are, no wait, is that kind of like a child and these are like parents? Or do they all occupy the exact same status? I'm not completely sure. But what I do know is that this object will not get dropped until all the references themselves have been dropped or have gone out of scope. So if I drop P1, I'm not going to be able to do the reference count on P1 anymore. But I could do it, for example, on P2, and that should give us the exact same number anyway. It doesn't matter which of these references we choose to do the reference count on. Let's try this. Yeah, and it says, so the reference count goes down to 2 and Bob gets dropped at the end. Let's actually put a print line statement right at the end here to clarify when exactly Bob is dropped. So I'll put in here completed. So if it's the case that this object gets dropped when we hit this closing bracket, then we should see this, and then we should see Bob is dropped after it says completed. And we can see that that is what's happening at the moment. Let's try dropping more stuff here. So I'm going to drop P2, and then we, of course, can't do the reference count with P2. We could do it with P3 though. So let's put P3. Oh no, I want to drop P2 and then use P3 for the reference count. All right, I think that's good. So let's try that. Something weird just happened with the zoom on my computer, but it seems all right now. I think it's the same zoom that I had before now. Okay, so yeah, it says completed and then Bob dropped. And there's one more reference that we could drop, obviously. And yeah, the reference count you see has gone down to 1 now. So we can drop that remaining reference, let's say drop P3. And I'm curious about whether Bob will get dropped at that point or at this point. So let's try this. When I do run, you can see now, instead of it saying completed and then Bob dropped, it says Bob dropped and completed. Because as soon as we delete the last remaining reference to that object that contains the name Bob, then that object will get dropped. And then the program just prints this out and that's it. So this is pretty straightforward, I think. You can find a write-up of this on blog.caveofprogramming.com, and I'm going to look at the next page in the documentation after this and make another video, hopefully next week.